In the Bohr model of the hydrogen atom, an electron orbits a single proton in the nucleus at a radius of 5.29 times 10 to the negative 11 meters, determine the speed of the electron. So just draw a picture of this out. We have this, which represents the single proton in the nucleus, and we'll have an electron going in this orbit around that proton. So the force of attraction between those two things, since this has a charge of E and this has a charge of negative E, same charge but just opposites, they're attracted, the force of attraction is given by Coulomb's law, which is the K, Q1, Q2 over R squared. In this case, the Q1 and the Q2 are both equal to E. Remember, you don't put down the positives and negatives, you just put down the magnitude, so E and an E. So we can say that is KQ squared, or KE squared, over R squared. So that's the force of attraction between the two. That's also going to be the centripetal force of this electron. Just like when we had the problems back in gravitation, where we had like a large mass, and then we had a smaller mass out here, and that smaller mass was orbiting the large mass, and we set the gravitational force equal to the centripetal force. It's the same kind of idea, only in this case, it's the electrostatic force equal to the centripetal force, the mv squared over r. So when you set these two things equal to each other, you see that one of these r's will cancel out, and nothing else will. So you can just take this and rearrange it to get this v by itself. So divide by m, and then square rootify it. So v would be equal to k e squared over rm, and the square root of that whole thing. So the square root of k is the constant, 9 times 10 to the 9th, times e, which is the constant, the charge of an electron or proton, 1.6 e to the negative 19, and that's squared, divided by the r, which was given in the problem as 5.29 times 10 to the negative 11, times the mass, and that's the mass of the electron that's in the orbit, which you can look that up in the chart on the previous page, is 9.11 times 10 to the negative 31. When you plug all that into your calculator, you'll get a final answer with a speed of 2.2 times 10 to the 6 meters per second.